Intel now previously worked for an employer that had a lot of green on their logos. And what's cool is Tom was actually a guest on the 10th episode of the Full Nerd, so it's been a while, but Tom is just a hoot to have on. So if you got questions about Intel Arc, which is just so much better, I've like already kind of left the other branding behind, and XeSS.
Yeah.
So bring them, but ask whatever questions you want. Tom cannot answer them. Obviously, there's, he would get in trouble. I don't want him to get in trouble, but please feel free to ask. And, it's just still fun to talk about.
Definitely. Ask a question I can answer, and then I get to talk about something else that I like to talk about. So that's the beautiful part.
Cool.
Nice. Yeah, we got people filtering in. It looks like we're holding steady. The ship is afloat.
Is everything working?
Working enough for me to get a paycheck, I think. So I'll take that.
Very good.
Did you really update the firmware just before we started?
I did. This capture card.
Oh, I never finished my firmware RAID 5 story. You know how that ended. You know how exactly that ended.
Jeez.
It didn't end well, did it?
That is still sitting in my closet because it's like, because now I have to figure out how to extract my files off of some obscure build of Linux.
Are you like the guy that's got a blockchain, like a password on your RAID 5 that you can't access? You've got $100 million locked up?
Probably.
Oh, man.
I'm that nerd that is like, I swear to God, there were 4 hard drives in the system when I built in 2012. How come I'm only seeing 2 now? Like, wait a minute, where did I lost one along the way? I don't even notice for like a year. It's like, what did I have on there? I hope it wasn't anything valuable. That's
a sign. You need some intervention.
Yes. Yeah. Well, that's because I've had such great luck with my NAS boxes. So I have a stack of NAS boxes I have to extract files off of.
Nice.
So
nice. There were a lot of NAS companies for a while. Are there still a lot of NAS companies?
I think it's settled down into a few. The reliable ones are still in business, I think is probably the way to phrase it. So, but.
All right, I think we're
ready?
We're good. Yeah. Let me take that off. Get this ready over here, and yeah, should be good to roll. Whenever you're ready, Gordon.
Oh, I got to change this intro.
The notes. You got to get the notes going.
Notes going.
Yeah, 189 episodes and.
Oh my God!
Is this number? Right? Is this 189?
I think so because I wasn't here for 188, so I'm going to assume we're on 188.
That's a lot.
Or actually, no. This is a special edition. There's no number on this one.
Really?
Yeah.
What?
Never mind.
What?
This is a special edition. Yeah, Tom Petersen gets us a special edition.
I don't get a number?
It's special. It's better.
Even better. It's limited edition. You can't get this Tom Petersen.
How many special editions have you had? Many.
I think probably 5, maybe 5 or 6.
Probably under 10. Yeah,
it's
under 10. Yeah, it is definitely more special than the other 189. That's just like
that's just a normal episode.
Except for number 10, which is a real standout.
Yes.
Yeah, number 10 for sure. Yeah, I mean, we should have done a special edition on that one. That's
Yeah, I think that's before we started.
Hindsight, right?
I don't know why we started the special edition.
I'm not that kind of guy. I'm self-actualized, meaning that I'm okay whether you call it special or not. That's fine.
I always wonder though, like, because they always get you with the special edition. Like, this is a limited edition of this. It's like, wait, you're in a business where you want to make more of these and sell them. So then you always go, I'm cynically, I know you're going to make these for the next 10 years. And then you kick yourself because they stop making them. And you got to go to eBay and then actually pay more than you would have bought if you just bought the damn thing retail.
Right now, you got to pay everything more on eBay, right? Yes. It's kind of crazy.
That is a crazy thing. That'll be part of it. And you know what? I'm going to get started because we're going to run out of time.
Let's do it.
11:30.
Let's do it. I'm ready.
Ready?
Yep.
In this episode of The Full Nerd, Intel's Tom Petersen talks Arc GPU and XeSS. Welcome to a special edition of The Full Nerd. I'm your host, Gordon Maung, with co-host Brad Charkis.
Hello, Internet.
And a very special guest, Intel's fellow, Tom Petersen.
Hey guys, great to be back.
And of course, Adam Patrick Murray, controlling the horizontal and vertical.
I'm back from vacation. I broke everything right before the show, so sorry about that. You're actually seeing me on a crappy little webcam. But Tom, the last time we had we'd seen you. It was episode 10 of the Full Nerd. That was a long, long time ago. Wow. You were actually with a whole different company. Now, some people are like, wait, he left Nvidia? Is this true? You're at Intel now?
Yeah, I've been busily beavering over at the Blue Team for a while and working on something that's really exciting that's going to be out here in the not too distant future. So we're starting to share a little bit about what we've been working on.
Cool. And I have 3 questions for you, Tom. I know we already know you can't answer them. Still got to ask. We'll ask up front. How fast is it? Is it going to be a Radeon and GeForce killer?
Well, Gordon, that is an excellent question. And right away, I'm not going to be discussing the details of performance, but I can say that, it's a brand new GPU. We've been improving the architecture ever since we started getting into the discrete business. And, this is sort of our second generation kind of for doing a full discrete card. And generation to generation, every kind of year and a half or so, we've almost doubled performance, starting from Tiger Lake and then going to DG1. And now if you think about our next step is going to be another 1.5x in frequency and about 1.5x in perf per watt. So in terms of average, kind of expectations, we're kind of moving the bar up. And the chip is not a tiny little chip. It's a, reasonably sized, not an entry-level GPU. So at the end of the day, without talking about perf, I'm pretty excited.
You will have a part that will compete, it sounds like. So
I feel like we're going to be competitive. Our hope is to be competitive.
And of course, the obvious thing in the world of GPUs right now, just simply breathing is enough to be competitive. Can we, now that's not to say anything that performance no longer matters, but can we get a hint at what supplies might be like, or is that just way too over the horizon too?
That is way above my pay grade. And unfortunately, I can't really talk about supply. It's a little bit sensitive, and it has a lot to do with not just what I'm talking about, but Intel in general and the industry at large. So I really, unfortunately, can't talk about supply. Although, Intel's a big company. We're working with big partners. So we hope to have adequate at launch. But it's again, something I can't talk about.
Sure. But in general, if you have only 2 vendors and a third vendor enters selling products, that generally means there will be more. So I think that's the takeaway people should at least
generally
understand.
More is good for everybody right now. It's good for all gamers to have more people competing for the discrete GPU business. I think everybody's struggling right now with where things are kind of crazy in supply and demand's off the charts. So I feel like this is actually a really great time for us to come in and expand the selection for everybody.
Okay. So I want to make sure I understand the official branding as well. I sort of thought XeHPG was gone, but I still see it mentioned in a lot of places. Is it?
It is a little confusing, Gordon. So the way to think about it is ARC is our big consumer brand. And ARC is really talking about, most games have a storyline, and our GPU, our journey is going to be a story as well. So ARC is kind of capturing that sense of adventure and journey. And I'm pretty excited about the name. And you'll see details as we get closer to launch about what comes underneath ARC, because I don't think we want to call everything ARC. There's usually ARC something, and how that all is going to roll out is something that we'll talk about in the future. And then you've got to start talking about architectures and code names and things, and that's where things start getting even more complicated. The way to think about our microarchitectures now is we're going with new names like Alchemist and Battle Mage, and these names are those big design efforts that you do every once in a while, like roughly Kepler or Fermi or Pascal or something like that. They're the architectural code names, and then over time you might see another code name that represents a chip or a specific feature, and something like XeSS, which we disclosed, could be called named totally different, just like say DLSS or FSR. So the naming is pretty simple. Consumers are going to need to know about ARC and ARC derivatives. Our code names are going to be based on these kind of epic characters from gaming, Battle Mage, Alchemist, and others. And then you'll hear about different techniques or different cores or different microarchitectural things in more kind of XE branded names, typically. But I'm not saying we're locked into the XE names. It's more just a way to get organized on names in your head.
Got it. But I mean, ARC for me is just easier. It's definitely easier to remember than the many forms of XE
Yeah, and Intel's been criticized in the past for crazy code names. We're trying to make things simple and memorable, because there's no point in having a code name if you can't remember it. So I would like it to think of Arc as a nice overall brand name, and then simple derivative names and simple architecture names.
Okay. I don't want to keep bogarting Tom here, but you got any questions, Brad? Because I was just gonna keep going.
Go ahead. You go ahead. You had a bunch of questions you said you can't answer, so I want to hear the answers to them.
Well, and of course, we'll ask it. He can't answer it, folks, but I know if I don't ask it, people will get hot over it. How much will Arc Alchemy cost?
Well, again, what's really interesting about it is I can't talk about pricing, but at the end of the day, we're going to want to be competitive. And almost effectively, just like today in the GPU market, the market really sets the price. We can kind of pretend what we want the price to be, but if it's too high, nobody's going to buy it. And if it's too low, it's going to get snapped up like that. So at the end of the day, our competitive position will largely determine the price.
Okay. And the last question, of course, we do sort of have an answer to, which is, when can you buy it? But, it's a pretty big window.
It's a big window. I think we've agreed to say Q1 22. So Q1 22 is coming up. There's a lot of stuff that's got to happen. The engineering teams are cranking and cranking and cranking. Everybody's like buffing this thing to make it just as beautiful as possible. But yeah, it's coming. So I want to ask, for me, what I sort of love, because competition. The reason why any journalist loves to follow anything is to watch the drama of it all. So the drama of this, everything basically to most reporters is basically a soap opera. So now you have green, you have red. They have been locked in this pitch battle for a decade or more. Yeah. And they're the only survivors of a dozen 24 graphics companies. Epic. So now we have Team Blue coming in, and we have Intel coming in, and I just sort of love this whole drama of, because AMD has very successfully played the guerrilla warfare. They've played the underdog against Nvidia, which has overwhelming market share in desktop and even more in mobile. And now you have Intel, this sort of third party. Where do you fit in here? Because you sort of have underdog, you have the clear winner. Where does Intel slot in? It is such an interesting time, Gordon. I got to tell you, I'm excited about it, because the market will sort it out. And all I can say is that Intel is entering from a place of humility, where we know we have a lot to learn. We have a lot to kind of grow our team and grow our expertise over time. But at the same time, we're no baby, right? This is not our first chip. We're a massive company, so we have the resources to enter in a big way. And I think what's cool about that is I'm not sure of anybody else that could do what we're doing. We're growing a large business from basically zero to hero in not a lot of time. And how that's going to disrupt the market is unclear, but it's very much going to be good for competition. Having Intel come in, and we're a science-oriented company. You're not going to hear us throwing around a lot of marketing stuff. We're basically going to say, here's what our thing is, here's what it does. It's great for games. Let me talk about our technologies. And if we can deliver parts at competitive prices with competitive performance with great features, then we'll make an impact on the market overall. But either way, it's good for gamers. Having more competition in this segment, which is so starved for capacity right now, is definitely going to be a good thing for the industry at whole. Now, the other thing we can do is, we're a standards-based company. Intel invented most of the standards, and we're going to do the same thing with, say, the game developers and game engine developers, where we can provide technologies that standardize across multiple hardware vendors. So you're not going to see us come out and say, hey, XeSS, that's our private thing, and please go integrate it just for us. Instead, we're going to say, a lot of people are building similar technologies. Can we have a standardized way to do an integration for a game engine? And then underneath it, let us differentiate. Let us build our own engines to plug in. But let's try to make life a little bit easier for the game developers and the game engine developers. So Intel has a lot of advantages coming to this, because we have all the relationships with the software ecosystem, and we have a great team that knows how to engage those guys. So to me, that's really what it's all about. We can bring our strengths, both from hardware development, process, chips, architecture, and couple that with a strong software focus, and hopefully, make it a little bit more competitive for everybody, and that's to the benefit of gamers and Intel, hopefully.
And so, clearly you have one side that very much likes to push, leading edge proprietary systems because that's to its advantage, and you have the other side again, sort of pushing that guerrilla open source approach to it. How does Intel fit in for both of those as far as?
Well, I would say we're kind of a middle. The truth is that there's good reasons to try both of those strategies. This stuff is actually very hard. Like developing graphics algorithms and developing software SDKs is not a trivial thing. So I don't think you'll see us ever just sort of do a reference design and stick it on a website and say we're good. So we're not going to be like open in the sense that we're not investing in developing that technology. On the other hand, being completely closed and proprietary and not standardizing APIs isn't good for the industry in general. So what we're going to do is the middle ground, where we're going to invest the software and hardware development expertise. Like we have some of the best machine learning AI engineers in the world. They're working on our implementation of XeSS. But the APIs that we're using to integrate with game developers are going to be public. The SDKs are already out, and we're trying to say, hey, let's be smart about this. Let's cooperate at the software level, and then we're willing to invest the time and the money to make our implementation kick ass. And I think over time, that's the strategy that's going to win. And that's one of the great parts about being the third person. We can come in and say, is there a way to cooperate together? And hopefully everybody will.
Hey, I have a follow-up question to that.
Sure.
That's actually pretty interesting. I look at, from what I've seen of XeSS so far, is pretty much splitting the difference between FSR and DLSS as far as the ethics behind it, like you were just saying. One thing that's interesting to me is that the Alchemist GPUs have so much XMX dedicated hardware, which are machine learning focused, kind of like tensor cores, right? A couple of questions I have around that being, one, you guys have put a lot more of that kind of hardware into your GPU than even Nvidia has. And I was wondering if there was a reason for that. And two, in the spirit of interoperability, I've never said that word out loud, I just realized.
Good job.
When XeSS does go open source, will Nvidia GPUs be able to tap into the temporal stuff because they have tensor cores that are somewhat similar to XMX?
Yeah, it's a great question. So first, let's start off with the chip design. Now, I'm not really deep enough into what NVIDIA's current offering is in terms of their tensor core ratio to sort of their SMs. But our ratio is picked because we think we understand the workload. And don't be confused, Alchemist is a gaming first device. It's not designed to be a compute first thing. It's definitely a gaming first thing. So the MXM units that are there are strategic investment. And the way you can think about it is there are some big winds that are blowing in the industry. And that lady or that guy coming down the street, his name is AI and machine learning. And right now that technology is being applied to post-rendered pixels with DLSS and our version of something similar called XeSS. But that's just the beginning. There's untoward algorithmic improvements that are going to come both to game engines and probably to games themselves to more deeply integrate AI style processing into all kinds of effects. So when you look at our chips and you see, hey, there's some heavyweight a systolic oriented architecture in there, what's that mean? It means that we believe that every processor is going to become more AI infused, and AI is going to be affecting more and more algorithms over time. So I'm pretty excited about that. Now, what was your second question, Brad? I'm sorry.
So since it's going to be an open technology at some point, is there the possibility for NVIDIA's tensor cores to tap into those temporal effects and whatnot? Because I know the fallback is DP4A.
Yeah, you're absolutely right. So the way I think about it is we want to define APIs that the ISVs can, the software guys can adopt and do one integration. And then what we're hoping is that underneath that, every hardware vendor would provide sort of like a kernel that is optimized for their hardware. So as an example, we have a team of guys that are in there with their like protractors and their tiny little loops, and every day they optimize a fine kernel for the MXM or units, the XMN units that are going to be the optimal fused kernel for this inference. It's like perfectly tuned. Now, we're not going to do that for AMD, and we're not going to do that for NVIDIA.
Of course not.
But we want them to be able to provide similar work that would plug into a standardized interface, right? That's the idea. Now, DP4A expands that dramatically because almost everybody has a DP4A style instruction, and we're making the code that does that style processing available publicly. So we're hoping that we'll just see that sort of adopted more globally. But again, everybody's got to make the choice. Do they do the work to make that investment? And we're hoping they will.
So how do you think performance with the DP4A fallback will stack up against the full-blown implementation?
Well, I don't have the data on DP4A performance yet, but we do know that, like, if you were to do just a pure vector implementation, that it's dramatically slower in many cases. And but the DP4A accelerates that a lot. But there's a trade-off of quality and performance, and it's going to vary based on the details of the algorithm. So I would say DP4A will probably be maybe a lower resolution version of it, or it could be a lower quality sort of upsampled image, but it's not clear yet exactly what the results are going to be.
I actually have a follow-up. You said earlier you said this was made for gamers. One of the great things that I've always found with getting a new GPU is that I can work on it and I can game on it. Or are you saying it's not going to be great for video editing applications or photo editing, things like that? So
definitely not saying that. It does have all the features that you'd want for creator. Intel for decades has had some of the best media functions in the world. We have dedicated media accelerators, we have encoders, we have decoders. So there's lots of good engines to accelerate media production, and that's going to continue to be carried forward. We also have a deep software engagement with all of the creator companies, and what's really interesting there is that now this whole how do you become a great creator device, it's all about how deeply can I engage with the software ecosystem to adopt your AI accelerators, because at the end of the day, that's really where creators are moving as well.
That's a good point. Do you guys have any game partners you're working with XeSS so far?
We do. We have several folks that are already integrating. I'm not sure if we've announced them. I would defer to Nick because I can't take the risk and say names if I'm not clear. Do you know, Gordon? Did we already announce a couple? I think we probably
I know
did.
There was an Unreal Engine 5 demo during the Architecture Day, so there's an Unreal engagement.
I think Lisa mentioned 2 titles that we're working with as well, but I unfortunately don't have them over the top of my head. Go check out Lisa's videos because I think she talked about it.
And I guess that's the time to ask. Although maybe that's what you ask at the end, but people want to know, can it run Crysis? And I've pointed out that in the actual demo reel that Intel showed off at Architecture Day, it did actually run Crysis. It was a remastered version, so it does run Crysis, folks.
It definitely runs Crysis. I remember running like the first version of Crysis and being like, this is amazing to see it. Do you remember like the very first time you saw Crysis, the first version?
Oh, yeah.
It literally was breathtaking. I mean, I had no idea. And it absolutely crushed. I think the part at the time, what was it? Was it like a 8800 GT or was it just the one 9800 GT, maybe something like that?
It was an 8800 GTX, and you could run a Tri-SLI 8800 GTX, and Crysis would crush it. And of course, back then, I do remember specifically because the enthusiast PC community immediately went from like, hey, bring it on, to like, oh my God, we've been crushed.
Yes.
Although I will say it's sort of the change because gaming has become so mainstream. Back then, Crysis was viewed as this, you have to be able to run Crysis. I got to climb that mountain. And it is so mainstream now that now if you did have something that got crushed, a game that would crush cards, people immediately start to complain rather than say like, wow, this is just incredible and I have to buy the next thing. It does speak to a different audience now.
I think when you see now there's going to be multiple hardware vendors that are basically providing these advanced features, DX12 Ultimate, all of the VRS, the mesh shading, hardware accelerated ray tracing, integrated AI engines. So there's now multiple hardware vendors that are all providing this beautiful landscape for software developers to really lean in. And there shouldn't be any, there should be great willingness to kind of lean forward in terms of effects. And you can see this whole Unreal Engine 5 demo is just sort of leading into what's coming for PCs. And as a gamer, I know you're a gamer, I'm a gamer, everybody's a gamer, but I've been a gamer for a long time, and I am super excited about right now. So it's good times.
Yeah.
I've a couple more driver-related questions. Peter Jansen was asking about support for legacy games like DX9, DX11, things like that. And then, who was it? Rolling the Dice was asking about, will you have full Linux support at launch?
Well, yeah, on all that, there's a huge install base of both DX9, DX11, DX12. None of that's going away, and we continue to work on our driver every day to make games run great. You can see we have a huge effort in terms of day zero drivers, just getting early builds in and making them work. And it doesn't matter what API they're using, whether it's DX9 or DX11 or DX12. We're going to make all of those work great. We also, of course, support Linux. We have an open driver strategy. You can go out there and we do early integrations with most of the major releases. So you can see our strategy is to, we love Linux. Linux is very important to us. Vulkan is very important to us. And we're never letting go of DX. So think of it as, you got to do it all. You want to be in the GPU business, in the discrete space, you have to sign up to a large buffet of software support.
And you guys the software team is working on bringing a lot of stuff that you see in like Radeon settings and GeForce Experience over to the Intel Command Center, right? Like overclocking and various other things like that.
Absolutely. And over time, you're going to see that's an area that we can, I think, add some value. I would love to figure out, and this is like me just talking about what I'd love to do, but we're an Intel CPU company, right? We have a large expertise in the best ways to manipulate CPUs, the best ways to tweak CPUs. Now we're also a giant GPU company. So the fusing of those two things over time, I think, is going to be a real opportunity for us. And expressing those interconnections in the control panel just seems natural. But stepping out of at the get-go, you'll see things like overclocking support, and you'll see some of the more common useful features of the control panel all visualized inside of our application for gamers. And over time, we're trying to just put the things in there that matter most to gamers, and everything else is. I'd love to see Windows UIs adopt the normal things like resolution and color and all that stuff, but it's a constant dance. We have to make sure that our users can get access to all the settings they need, and sometimes that makes the UIs a little bit more busy than they need to be. But over time, we're definitely separating. We want it's kind of like the basic controls to be in Windows, and the more experienced things that are unique to Intel to be in the app.
Speaking of the app real quick, Decoy asked earlier a very important question. Will that app require a login to use?
No.
Okay.
Not now. But I'm not against the login, just to be clear, because there's a whole world of ecosystem things that we can deliver with a login. And while we have no plans to do that now, if we can think of features or service or anything that could be delivered with an account, we'll definitely add that. I don't think there'll ever be a time where you get basically no functions unless you have an account. Think of it more like the account would let you into things that need an account. And that's probably the way you'll see it go.
I know it's over the horizon as well, but do you think you're going to go to an add-in board model? I mean, you'll probably we imagine there will be Intel reference designs at first, just a seed, but then will it sort of mirror what the other graphics vendors do? I don't want to talk about our go-to-market strategy for discrete because there's lots of time to talk about that as we get forward to it. But I do think that it's an area that is not obvious what we should do, right? You could do the AIC model where basically we build reference designs and send them off to our partners in Taiwan that build them and then differentiate. We could go direct because, obviously we have a direct sales model. We could even do something different like a hybrid. But right now, I think that's just one of the exciting parts about being Intel. We've got some great business guys. They're working through what's the best way that we can help both our customers and our gamer customers see the value that we're doing on GPUs. And we don't have to live within the current channel distribution model.
We actually had a super chat from VC Jester. Thank you so much. $2 said, will Intel be making these GPU chips in-house? Can you talk about that at all?
Well, we're certainly designing in-house, but even today, when you say design in-house, this is a massive disaggregated effort. And we have IP suppliers that we work with, and we have downstream partners that build chips. We're designing and verifying and doing all the software for our discrete cards in-house. But we're manufacturing these cards or these chips at TSMC, our partner for Alchemist. So if you think about it, this whole in-house, out-house thing, in-house or outsourced, it's all very, very complicated. It's very, very fluid, and it's never black and white, especially not anymore. But we'll make these decisions, and one thing that's great about our IDM 2.0 strategy is we can make these decisions per device. So you won't see us always be in Intel fabs or always be in TSMC fabs. We're going to be very flexible and do the right thing in terms of manufacturing for the devices that we're making.
Nice.
Okay. Well, I would like to go back to XeSS for a minute.
Yes.
So DLSS and fidelity effect super resolution, they're already known quantities. They're out at this point. I was wondering if you could just explain the differences for people who might not know between XeSS and those, already out there.
Sure.
Solutions.
Well, let's start with, there's a lot of confusion here because people are muddying the waters. The way I think about the way these techniques generally work is there's pretty much two fundamental approaches. One is I take pixels from the current frame, and then I'm going to explode them. And I'm going to use a variety of techniques. Some can be looking at one frame, some can maybe look at another frame. But the idea is that we're going to take limited information because it's not rendered. It's just the limited information. We're going to scale it up. And there's a bunch of techniques that look pretty good and they operate pretty fast. That's what I'm going to call super scaling or up-res, right? Now, super sampling is a pretty different technique. And the idea is let's use multiple pictures from the past and let's use billions of cycles of training a network to kind of extract essences of what the gaming pictures look like. And we're going to encode that into a network that then we can take the older images, like maybe 3 or 4 or 5 or 10, who knows, how many images back in the past. And we're going to use those to predict what should the perfect image look like in the present. We're using a low resolution image right now, but we're also using all of that other information to synthesize this fantastic new image. And you can see in the demo that Lisa showed, it looks great. I mean, the text looks better than you would ever expect. Some people are even saying this is fake because that text, look at it, the text in the 4K doesn't even look as good. Well, the truth is we're looking across multiple frames and you're seeing different samples of offsets of that text. And then we're synthesizing all of those offsets together to generate that one final image. So what we're talking about with XeSS is all about this AI-infused multiple frame motion vectors, calculating the right pixels to put on the screen. So it's a very different algorithm, and that's why you need a little bit more hardware to make it work well. That's what the XMX blocks are on Alchemist. So that's my way to think about it. Now DLSS, I don't have the details of what DLSS implementation is, but I can tell you ours is all based on deep learning technologies using the matrix matrix blocks inside of Alchemist, and it looks great.
Is it generalized like DLSS 2.0 is, so it'll just work with any game if, they support it? It's
not game specific. So the training and the network styles that we've done, train once, run on many games. It's the only way this would ever work. The idea of having multiple different network weights for each with one game support, that model just breaks down pretty quickly, as you could see from the early versions of DLSS. This version, our XeSS, is game independent. Now, it doesn't mean it doesn't require game integration. It certainly does require game integration, but it's not a network that is per game.
So some of the other techniques that are out there, they do very, very well at 4K and 1440p, but once you step down to 1080p, image quality can sometimes suffer because they're jarring off so many fewer pixels. Seeing as how you guys purposefully designed this to also work on the Xe integrated graphics, I was wondering if you have any thoughts about how XeSS will perform on that lower resolution.
Well, the demo we showed was 1080p to 4K. So if you look at that demo, it looks fantastic, right?
I mean, on 1080p screens. Like, if I have a 1080p laptop, how will XeSS? How will that look? Because FSR kind of stumbles. DLSS sometimes has issues.
I haven't looked at it myself directly. Like, you're talking about a 640p render up to 1080p kind of thing. Yeah. I think it can look reasonably good, but honestly, I haven't seen it myself. And it's unclear whether or not that would be a mode we offer. It kind of will all need to be figured out as we start seeing more results. And if it, honestly, if it looks great, tastes great, smells great, make it available, right? But right now, it's not known.
Okay.
We got a number of questions in various different forms of the chat asking about mining. Are there going to be hash rate limiters? What are you going to do to combat mining and scalping and all that sort of fun stuff?
So mining and scalping and all that stuff, all that jazz. Well, let's start with mining. I'm a gamer, and I'm not against mining. It's just that it seems tragic that mining and gaming are going after the same GPUs, because I think what's happening is the gamers are losing out in that race. And I'm not familiar. I don't believe we have a mining avoidance plan right now. It's still a little bit too early in our evolution. But on the other hand, scalpers, another one of those examples where it's an unfortunate phenomenon right now with bots grabbing cards and again, escalating prices. And that's more about a channel question. How does the channel work, and how can the channel provide some kind of access to cards that skip scalpers? And again, that's not really much that we can do about that, but it's certainly on our mind. And if there are ways, whether we go direct with some amount of cards or something like that to try to help some of this, it's a very tough problem. And I don't think there's any magic bullet right now that I'm aware of. The hash rate limiting stuff, I think we're going to have to, be a little bit quiet on that. It's not that we're not going to do that. It's just that I don't think we don't have an articulated plan about that right now.
Okay. Moving over to some more questions that I'm interested about creative applications. We got a $10 super chat. Thank you so much from Nori SS asking how about the encoder performance? Will it rival or beat Nvidia's NVENC encoding quality versus performance? Obviously, they kind of own the market when it comes to that kind of stuff.
Yeah, that's an excellent question, and unfortunately, we're not going to give out a lot of new details about our encoding performance right now. All of that information is going to come when we actually launch our product. There's a long history of encoder behavior with Intel. You can go look back at all of the technology, quick sync, and all that. We know what we're doing with media, but we're not talking about it right now.
Okay.
I'm going to ask a follow up on that, and
sure.
A lot of that feels very much like DevRel, kind of like the strength is because NVIDIA jumped in there with Adobe years and years before anybody really saw any opportunity. And how hard is it to get in there to, content creation developers and get them to adopt stuff?
I don't think it's so for Intel, it's not like we have to get in there. We've had a long relationship with Adobe. We have people that work with Adobe every day. And, we understand what their needs are and how we can help them. So at the end of the day, we really want to help them help their customers, and we're all aligned in that goal. So I feel like we are unique in the sense that our CPU engagements with all these different creator ISVs help us with the GPU acceleration that we want to now do. But you're right. It is all about developer relations and content tech, and I feel like we're in good spots with that stuff.
So this is again, I don't know what you can really say about this, but I think a lot of people kind of fear that you may be bundling, because it's just easy to say you buy a chipset, you buy a CPU from us, buy the GPU too, and I think people really don't have an issue with that, except the fear is for the gamer, the DIY gamer that's going to go out and buy one single card. That feels like it just may take so much inventory out of their hands right now, because it feels like job one is just getting hardware into gamers' hands. So instead of
unfortunately, system. I think that's a good question. I really feel like that's the first question that I really don't even want to pretend about, right. Because of the long history of that question at Intel. Yeah. So rather than get fired in my first couple of years, I think I'll just go, good for you, Gordon. Good question.
Good. Yeah. We'll answer that later.
Get back to my PR guys, and we'll call you.
I have a totally different question then. I have a totally different question. Since you're on the line, I was always wondering, now I have a chance to ask, So is there a way that you guys quantitatively measure the visual performance of upscaling techniques like FSR and DLSS?
Yes.
Like, is it all subjective? Is there quantitative?
Yes.
Yeah.
Yeah, it's super exciting, and this is an area that I probably want to work with you guys a little bit more. Is now we're in this mode of transition where we're going from pixel accurate rendering is the only thing we care about. How quick can you do pixel accurate rendering? Now we're into a whole new world, which is how quick can you generate some image, and that image may be good or it may be bad, but you did it really quick. We want to help the industry learn how to quantify how good those images are. So we've developed some internal tools that right now do like you give it a movie, it kind of looks at the images in the movie, it compares it to some base known reference images and generates a heat map of error based on perception. So there's some simple mathematics that you can do that will calculate, different noise ratios, and there's another one that's like a perception AI network looking at each individual region of the pixels. So I'd love to figure out how to make that a thing. Like, how do we make that perception measurement standardized? Maybe get some friends at Nvidia to talk through it with us. But we'd love for moving the ball forward, making quality less arbitrary, making quality more science-based. And there is some good science behind it. We use it internally.
Okay, great. Because that does kind of seem like that's where the industry is heading these days. So
yeah,
it's really hard to compare apples versus oranges versus bananas.
Impossible. It's impossible. If every review has to be based on look at this movie, it's too hard, and there are too many cheaters out there to make that be the way it goes. I would rather say let's get some science deployed here. Let's make some easy to use tools, and then let reviewers figure it out. That's the way I'd like to make it work. Okay. It's a complex topic, though, Brad. I mean, there's no easy way to describe the quality of two images to a user that they're going to understand.
And it is very subjective too. I mean, somebody may accept blur somewhere, and some other reviewer may hate it. So
yeah, well, that's the science here. Is that it feels very subjective right now, but if we built a process that uses lots of samples of people's perception of how pixels look, maybe we can generalize that into some kind of AI-based evaluation tool, and then that would be, we would all agree that this is probably better than just subjective. But that's work to be done. But we'll probably be in touch as we get a little bit closer, and maybe that tool would be something you guys want to give us some feedback on.
Okay, awesome. So you've worked on stuff like Nvidia multi-res shading in the past, I assume, foveated rendering and all that stuff. AMD does something similar with Radeon Boost. Going forward, now that it seems like all the two big GPU companies, you guys are about to enter as the third, are so focused on image upsampling, do you think there's still room for technologies like multi-res shading, Radeon Boost, stuff like that?
Oh yeah. I mean, the whole question of our goal as a GPU company is to take a theoretical model of a scene and generate a bunch of pixels that users like. So one way to do it is to generate pixel accurate images, but that's very expensive. So what we're looking for are these techniques that can reduce the render load and then do more processing on the pixels to make them look better. And that's a net win for our customers. And so the question is, what's the set of tools that we can deploy that will implement that thing? Super res is just one, or super sampling, generating images from multiple pixels, multiple samples is one way to go. But I think there's a lot of other techniques, and multi-res shading or VRS style stuff is a great example, but there's many others that maybe would even go deeper back in the pipeline of graphics. Maybe you don't need to do tessellation anymore. Now maybe you can do some kind of AI decimation where you're actually reducing the geometric complexity of things dynamically, trying to optimize performance without impacting visual quality. So to me, there's like this whole world of AI applied to graphics, and the subsampling stuff is just one example.
Excellent. Now it's starting to make sense why you guys have so many XMX cores.
Someday maybe they'll do something really cool, right?
I do have a question about, there's suddenly this fixation on the upsampling. Is this a recognition by all the graphics vendors that we are not going to continue to scale up to 8K and beyond very easily, and we need upsampling is probably the only way to get there?
I don't know, Gordon. You and I have been doing this for a long time, and it seems like every couple of years there's one of these, oh, Jesus, how are we ever going to render at 1080p? That's never going to happen, never going to happen. But every time, people find ways, and this is just along that journey, where Moore's Law is not dead, technology is not stopping, and graphics innovation is really just getting going. And I feel like I'm excited to see all the upsampling and super sampling techniques, but honestly, there are other techniques that I'm even more excited about. So all of that stuff is great. And if we can deliver better experiences because of it, then we're all winners, right? I would love to figure out, how can you do like fully hallucinated images that are correct? When I say hallucinated, I mean AI. You've seen like these big fakes and all that kind of stuff, deep fakes. Those are hallucinated pixels that were never presented to the network. The network just got trained on Obama, and then it took a picture and it kind of created a picture that's like Obama. Well, if we did a good enough job, you could actually someday imagine, well, all of this traditional rendering that's happening with, triangles and textures and shaders, maybe all of that someday could be sort of reduced, and you're taking those raw inputs into a network. Like in Nirvana, you love these networks to just do it. Like, why is there not an AI to do rendering? It's because it's super complicated and it'd be a giant network and there's optimizations, but that's the way we're really heading, I think. AI, man, it's big. Trust me, it's gonna be big.
I have a couple platform questions. Man, somebody asked it earlier. Pilukun was asking about if somebody has an Intel CPU and an Intel GPU, what kind of benefits can they get from having both? Will there be a way that it'll play better together?
Well, we hope so, and it's an excellent question because it's one area that I am super excited about. We invented a technology last year. We called it Deep Link, and what Deep Link does is it's different. It's like an umbrella. It's a collection of technologies where the integrated graphics works better with a discrete graphics that's Intel. Well, Deep Link also talks about, well, it's an Intel CPU working better with an Intel graphics chip of some kind. Right now, most of those technologies are either related to media offloading or it's related to power management. So if you think about it, balancing better between the CPU and the GPU, that's an obvious thing that Intel can do better together because we own both pieces of that silicon, both stacks. But there's a lot of other opportunities. I mean, the nirvana would be, hey, can I use my integrated graphics inside of the CPU to do something useful in render while I have a discrete graphics chip from Intel? That would be nirvana. And so imagine that we're trying to figure that out. It's super, super difficult. But the good news is there's already something called hybrid. And what hybrid is you render on a discrete GPU and you copy that image over to the integrated GPU, and that's what displays. So that data movement is already happening, and it happens not just for Intel graphics discrete plus Intel iGPU. It happens for Nvidia graphics discrete and Intel integrated graphics. So that data is right there. We just have to make sure we use these little brains and figure out what would be useful to do in that spot. And it's things like super sampling come to mind, right? Where you say, I've got a nice graphics chip, a nice GPU sitting right here. I've got an image. I'm getting ready to display it. What should I do to it? There's lots of good stuff there.
Yeah, why not use the silicon you've paid for on the chip, right? Why not put it to work?
Yeah. And honest, Gordon, if you have any good ideas in that space, I'm all ears, because if we solve that problem, you and me right now, straight now, we are going to be somebody.
Well, we'll do it offline and then we'll patent it and then we'll sell it to somebody.
Yeah, that would work out for me. I can tell you right
now. Kind of a funny question to piggyback off that one. Flash Photo asked earlier, will dual GPUs be a thing with Arc? Can you bring that back?
So I think what was the name of the questioner again?
Flash Photo.
Flash Photo, nice name. Well, I think what Flash, can I call you Flash? I think what Flash is talking about there is SLI,
yes,
or Crossfire, and those technologies I think were super awesome right around DX9 timeframe and a little bit of DX11 timeframe, but they kind of fell on their face during DX12 timeframe because what's happened is frames, game engines and games are doing post effects that rely on looking backwards through multiple rendered frames. So if you're doing a blur, you got to kind of know what was the prior frame plus the current frame, and that serializes the render process. So you can't do one graphics render and another graphics render of a different frame on a different GPU and then just display them, because they're both interconnected. So that's what basically made SLI and Crossfire ineffective. So what we need now is a different method of distributing work across multiple GPUs and then bringing it back together in a way that has an additive benefit. And that problem, trust me, is very, very difficult. So until we solve that big nut, I don't think there's going to be a multi-discrete GPU thing that matters at all. But that's not to say that if we solve that nut, that would definitely be a thing. But that's different from what I'll think of as multi-chip devices. So if you look at a lot of devices today, they're being manufactured with multi-chips. And I think that technology is definitely going to come to graphics, where you have a very high bandwidth interconnect, much like what we're doing with our current Alchemist, where there's a very high bandwidth L2 cache with high connections between these cores. If you could do that on a multi-chip package, well, then it's not really multiple chips anymore. It really looks like one big chip. And so I think that will happen, and that does require software work, but it's not going to be crazy. Someday, I think we're going to be coming full circle and seeing multi-board, single frame processing, but we're just not there yet.
And I mean, the problem there is that there's just not, even I would imagine PCIe 5 would not be enough for that.
Not at all. Not even close.
So
now, if you think about CPU or GPU or even system architectures, there's this thing called SMP, symmetric multiprocessing, where every device sees all the memory uniformly from every other device. But there's also another thing in compute called CC-NUMA. And what CC-NUMA is talking about is every cache is an island, and some latencies are very short and some latencies are long, and there's protocols to make it look like it all is symmetric, but it's really not. Now that's really more likely the scenario that we're going to end up in on graphics, where there's like different latencies depending on where the data is. And so you would need a new software paradigm for managing memory in that case. And it's possible. It's just a giant chunk of work. And someday I hope to look back on 2023 or 2022 and say that was the year that blah, blah, blah invented that blah, blah, blah thing. And now, we can do great scaling of GPUs again. So someday.
I got a couple more questions before we get out of here. Reps Up 100 was asking, and other people were wondering, will Intel Arc work with adaptive sync monitors?
Absolutely. Adaptive sync near and dear to my heart. And I would say that we're going to do a great job on adaptive sync. I will also tell you that all implementations of adaptive sync are not the same. And so even though there's like an adaptive sync monitor, there needs to be significant work done on the driver side and also in the ecosystem side to make sure that's a great experience. So having Intel come into the space and supporting adaptive sync, I think will give that ecosystem the boost that it needs to get cleaned up a little bit. And I think when we launch Alchemist, you'll hear a lot more about how can we make it the adaptive ecosystem much better.
Maybe if Intel comes up with some branding, and then you just simply have monitor makers put a logo that says Intel maybe Intel Sync compatible.
Gordon. Gordon.
It works.
Wouldn't that be a great idea? I will say that there are some real technology issues with adaptive sync and G-Sync. I hate to say it, but there are. And we can fix a lot of that in the driver and make the experience of adaptive sync monitors awesome.
Nice.
No, and I agree. It is a mess. Adaptive sync is still a mess, but
Yeah, and I don't know if a logo or a brand alone would make a difference. You don't want to. We would not want to come out and say Intel Sync compatible with a logo if it sucked.
Yeah.
Right. It would need to be awesome, and I think that's the idea.
Cool stuff.
Kind of an in-depth question from Mike Buzzone. I'm gonna
let's call him Mike.
Yeah, Mike, good old Mike, friend of the show, Mike. Well, multiple questions, but I'll stick with the first one first. Will consumer GPUs stick with 7-nanometer legacy on depreciated cost for mass market volume versus increasingly costly nascent? So 5, 4, 3.
Great question. I think at the end of the day, there's always a business balance between pushing the bleeding edge foundry process to get that big die shrunk down so you can get adequate yield to have a product. And maybe that's going to raise your cost initially, but then as the process matures, you ride that cost wave down. The whole decision is smart. But my experience has been waiting just a little bit for the volume parts makes the most sense in economic terms. But these are questions for our expert business guys. They have very detailed models about cost curves and yield and defect densities and sizes of chips and all that stuff. And every chip and the process that it goes into is a very complex decision. So unfortunately, there's no general answer to this question, but we will definitely be riding the technology trends forward in discrete graphics. And you'll also see older chips or some other chips that make more sense in older processes. And whether that's a performance cost thing or maybe it's a capacity thing, there's lots of reasons why you'll see a collection of technologies over time.
Nice. We do have a laptop question. Rowan,
do it.
Yeah, Rowan is asking. Obviously, if it will come to laptops, but will Intel still release laptops with AMD or Nvidia GPUs once ARC has taken off?
Well, let's see. I feel like I don't want to answer that question, but I'll give you a little bit of hint to that.
Intel doesn't release laptops.
I will answer it. Intel doesn't make laptops. That would be up to MSI, ASUS, Dell, HP, etc., Lenovo to make the laptops. I would think they always work in their own business interests. So I'm going to guarantee you there will be Intel and AMD CPUs paired with Intel, AMD, and Nvidia GPUs going.
That is an excellent answer.
In the near term, although I'm looking forward to Intel having control of CPUs and GPUs, as well as AMD having control of CPUs and GPUs, and how they can make them both work closely to improve our experience. But I'm also sort of afraid that eventually comes to a head with, everybody always playing nice. So we'll see how but that is so far away.
It is.
I don't know.
It's not a problem that we have in the short term for sure.
Yeah, definitely not. But he can't answer that, but I already answered it. You will be able to. There will not be. No, there will not be. So there will be.
Good answer.
I'll answer that. Don't answer the question. No, that's when that.
Excellent. All right. So I've got a little bit of time. What do you got left on your list?
Adam, any more for the audience? Because I definitely want to get the audience. Or Brad, I don't want to. I have to ask plenty of questions.
Oh yeah, no, Brad, go ahead.
No, you go ahead. I've crossed off. I have a big list. You can't see it with the Zoom background, but I crossed off most of them.
Nice. Well, I like to be open and talk about what's interesting.
Yeah, we got a quick one from John Dokic. Gave us $2. Thank you so much. Said, will we see Octane chips on GPUs?
Ooh, I don't know the answer to that, but I can say it's an interesting idea, like having a large non-volatile storage on a chip. I don't think it really matters right now for most gaming cards, and I don't think the ROI would make sense for a gaming card, but there might be some larger compute style data-intensive AI thing for it. So I would say I don't know, but maybe. Good question.
Last fun question. Chris Livingston asked Tom if he gets to hang out with Ryan Shrout. I love their old PC Per interviews.
I love Ryan. Unfortunately with COVID, I don't get to hang out with anybody. With COVID, what I get to do is sit in my room here. This is what I hang out with in COVID. But I do love Ryan. He's had another child. He's got a little boy and a lovely little girl, and they live in Kentucky. And I get to see him about once a month on video. And I've invited him here recently, but he hasn't come. COVID, man.
So I want to ask one last question, Tom, because I know you got to go. This has been wonderful. Thanks for being here. But so obviously, Intel, you're going to be coming out with this shiny GPU. The entire world is rooting for Intel, which is frankly a different. Let's be honest. It's
great.
As a Warriors fan, nobody likes Warriors, and and you're going to be in this fantastic position. There's going to be an element that says it's going to be the accountants. They're going to say, let's make some money here. I would encourage Intel. You know what? AMD and Intel have been messing with you for years and years and years. Here's your chance for a little payback. So just make it so Jensen and Lisa take their paperweight and throw it across the room at the bulletin board. And I say that because I think Intel being as disruptive as possible to AMD and Nvidia is good for consumers, good for gamers. So that's my suggestion, to push back against the bean counter and say, hey, you know what? Let's book some revenue. I like revenue. Shareholders like revenue.
I like revenue.
Let's think long-term revenue. We're building a brand here.
One thing I would so Gordon, thank you for that. And I think all of us at Intel appreciate that, we're doing something hard and we're coming from a place of humility where we just want to get good work done. And we're not going to be overhyping what we're doing. It's going to take a long time, and there's a lot of work here. It's complex stuff, but I'm excited with the progress that we've made. And we have the support from our board and from our executive leadership. And I feel like, we're on a really great path. But we're going to need help. We're going to need help when we get out. So Gordon, looking for it. Brad, looking for it. As we get closer and we start having, hey, here's our little baby. Here's our baby. That's when it's really going to get real. And I'm excited about it.
I think everybody is too. So, clearly the excitement is there. So
yeah,
just got to see some parts.
Cool.
I'm with you.
Let's take us out, Gordon.
Okay, thank you for being here. Check back next week for your fix of PC Talk on the Full Nerd for audio listeners. Subscribe to us on iTunes, Google Play, Spotify, and Stitcher. And please leave a comment or review every time you do. Intel messes with AMD and Nvidia graphics to the betterment of gamers. Send questions and comments to thefullnerd at PCWorld.com. Thanks for coming. I'm Gordon Ung with Brad Sharkus.
Adios.
Tom Petersen of Intel.
Thanks, guys. It's been great to talk to you.
And Adam Patrick Murray's going to hit the off switch.
Nori SS wants to know, are we getting Zachary's Pizza after the stream? If so, who's buying?
I had some on Friday.
Okay. Yeah. All right. Let's get out of here. Bye, everybody.
See you guys.
Oops. Wrong button.
Thanks, Gordon.